What is a solar flare? Imagine the sun, a giant ball of hot gas, suddenly releasing a burst of energy. This burst of energy, a solar flare, is like a cosmic sneeze from the sun. Solar flares are powerful explosions on the sun's surface, capable of disrupting our technology here on Earth. They are a reminder of the immense power of our nearest star and its potential impact on our planet. Solar flares appear as bright flashes of light, releasing as much energy as billions of atomic bombs. These flares are not just bursts of light. They unleash a torrent of high-energy particles into space, traveling at incredible speeds. Understanding solar flares is crucial for protecting our technology-dependent world. The birth of a solar flare. Deep within the sun, a constant battle between magnetic fields rages. These fields, generated by the sun's churning plasma, twist and turn, storing immense energy. Solar flares occur when these tangled magnetic fields cross and reconnect, releasing their pent-up energy in a sudden, violent explosion. Imagine twisting two rubber bands until they snap. That's similar to what happens with solar flares. The released energy heats the sun's atmosphere to millions of degrees, causing it to erupt in a dazzling display. This eruption hurls a wave of radiation and charged particles into space, traveling at speeds that can reach Earth in just a few hours. Frequency and reach of solar flares. Solar flares are a common occurrence, happening multiple times a day during periods of high solar activity. The sun goes through cycles of activity, with periods of intense activity known as solar maximums and quieter periods called solar minimums. During solar maximums, solar flares are more frequent and powerful. The reach of a solar flare is vast, extending millions of kilometers into space. Fortunately, not all solar flares are aimed directly at Earth. However, when a powerful flare does erupt in our direction, it can have significant consequences for our planet. When a solar flare erupts towards Earth, it unleashes a solar storm, a barrage of high-energy particles and radiation. These particles interact with Earth's magnetic field, causing geomagnetic storms that can disrupt our technology. The most common effect is interference with radio communications, as the charged particles disrupt the ionosphere, a layer of Earth's atmosphere. Solar storms can also impact power grids, causing widespread blackouts. The fluctuating magnetic fields induced by the storm can overload transformers and other electrical equipment. Satellites, too, are vulnerable to solar storms, as the high-energy particles can damage their sensitive electronics and disrupt communication signals. In 1859, the most powerful solar storm ever recorded struck Earth, known as the Carrington event. This massive geomagnetic storm caused telegraph systems worldwide to fail, with some operators reporting electric shocks and fires. Auroras, usually only visible near the poles, were seen as far south as the Caribbean. The Carrington event serves as a stark reminder of the potential havoc solar flares can wreak on our technology-dependent world. If a similar event were to occur today, the consequences would be far more severe. Our reliance on electricity, satellites, and global communication networks makes us incredibly vulnerable to solar storms. A Carrington-level event today could cripple our infrastructure, causing trillions of dollars in damage and widespread disruption. As we continue to rely more heavily on technology, understanding and mitigating the risks of solar flares becomes increasingly crucial. Scientists constantly monitor the sun, tracking solar activity and developing forecasting models to predict solar storms. Space weather forecasting is still in its early stages, but it is crucial for giving us time to prepare for potential impacts. While we cannot prevent solar flares, we can take steps to minimize their impact. This includes hardening power grids against geomagnetic disturbances, designing more resilient satellites, and developing backup communication systems. By understanding and preparing for the sun's fiery outbursts, we can protect our technological infrastructure and ensure a brighter future.